This video will discuss the notion of random process. To define the random process, first we should know what is random variable. I would like to recall the definition of random variable first. Random variable is a function that assigns a real value to every outcome of a sample space. For better understanding, I'll give an example. Consider an experiment of tossing two coins together and let x be the variable which denotes the number of occurrence of head. It is a well-known experiment. The outcome of tossing two coins together are head head, head tail, tail head, tail tail. In the first outcome head head, there are two heads. So it takes the value 2. That is, x assigns the number 2 for the first outcome head head. The second and third outcomes only one head is there, so it takes the value 1 or it mapped on to 1. And in the last outcome tail tail, there is no head, so it takes the value 0. Now let us see the definition of random process. Random process is a function that assigns a time variable t to every outcome of a random experiment. That is, it's a collection of x of s comma t, where s belongs to capital S, that is sample space, and t belongs to capital T, that is parameter set. For example, x is the number of persons arrived at the station in the time interval 8:30 to 9 am. Here S is the number of arrivals, that is outcome of an experiment. S is the number of arrivals and T is time interval. So it's clear X is a function of S and T. Next is classification of random process. We know that random process is a function of S and T. Depending on the discrete and continuous nature of S and T, it is classified into 4. That is, and S is a state space, may be continuous or discrete. Same way T is a parameter set, it may continuous or discrete. If D is discrete, then x of s comma t is generally called as sequence, and if t is continuous, then x of s comma t is generally called as process. Now the classification as follows. If S is discrete and T is discrete, then it is generally called discrete random sequence. If S is continuous and T is discrete, then it is called continuous random sequence. Then if S is discrete and T is continuous, then it is called discrete random process. Same way, S is continuous and T is continuous, then it is called continuous random process. Now let us see few examples for classification of random process. Consider xn represents the outcome of the nth toss of a fair die. Here experiment is tossing a fair die. We know that the outcome of tossing a die is 1, 2, 3, 4, 5, 6. It is a finite set, so it is discrete. And T is number of tosses, that is, it takes the value 1, 2, 3 up to infinity. That means it is a countably infinite set, that is discrete. Both S and T are discrete here. So here Xn represents discrete random sequence. Now let us see an example for continuous random sequence. Consider Xn denotes the temperature at the end of nth hour of a day. Here S is temperature function, that is, it is continuous and it is taken at the end of nth hour of a day. So T is a set of nth hour of a day, that is, it takes the value 1, 2, 3 up to 24. That is, it is a discrete set. So S is continuous and T is discrete here. So Xn is an example for continuous random sequence. Next is an example for discrete random process. Considered x of t denotes the number of telephone calls received in the time interval 0, t. Here S is a number of telephone calls received. That is, it takes the value 0, 1, 2, 3, etc. up to infinity. That is, it is countably infinite set. Therefore, S is discrete set. And it's very clear t is nothing but a time interval 0, t. So it is a continuous set. So S is discrete and t is continuous. So this is an example for discrete random process. Now example for continuous random process. Considered x of t denotes the maximum temperature at the place in the interval 0, t. It's clear S is the maximum temperature function, it is continuous, and t is the time interval 0, t, so it is also continuous. S and t are continuous, so above is an example for continuous random process.